dragonflies 1 meter wide, and scorpions 70 centimeters long. Such arthropods once existed on our planet. In this video, I will tell you about ancient giant creatures that once lived on Earth. Pulmonoscorpius. Pulmonoscorpius was a prehistoric species of scorpion that lived around 350 million years ago. It could grow up to 70 centimeters in length, making it much larger than any modern scorpion. Its name translates to lung scorpion, thanks to its efficient respiratory system, which may explain its large size. Its enhanced ability to breathe was an advantage in the oxygen-rich atmosphere of that period. Fossil remains of Pulmonoscorpius, mostly found in Scotland, show that it was a formidable predator of its time. Its large size, combined with typical scorpion traits such as claws and a venomous stinger, made it a dominant hunter, preying on smaller arthropods and possibly even early vertebrates. Arthropleura. This is one of the most fascinating and mysterious creatures of the distant past. Arthropleura lived about 300 million years ago. They were arthropods, resembling modern millipedes. However, their size was truly colossal. They could grow up to 2.5 meters in length. Just imagine encountering such a millipede today. These giant arthropods roamed the humid forests that covered much of the land at that time. Their size suggests that they dominated their ecosystems. Today, however, scientists believe Arthropleura were herbivores rather than predators like many modern arthropods. Their massive bodies were likely used as a defense mechanism against predators. Their bodies were covered with hard plates, providing reliable protection. Mesothelae. These ancient spiders lived about 300 million years ago. While they were not as massive as once thought, they were still larger than many modern spiders, with some species reaching up to 10 centimeters in body length. Their body structure was more primitive than that of modern spiders. Unlike today's species, their silk-spinning organs were located in the middle of the abdomen, not at the end. Scientists believe these spiders may have used burrows for shelter and possibly for ambush hunting. Their anatomy suggests adaptations for a predatory lifestyle, lurking and waiting for prey. Titanomyrma. Titanomyrma was a genus of giant winged ants. They lived around 50 million years ago, during a time when much of Earth had a warm climate. Fossils of Titanomyrma have been found in North America and Europe. The most striking feature of Titanomyrma was its size and wings. The largest specimens had a wingspan of up to 15 centimeters, making modern ants look like dwarfs in comparison. The reason for the evolution of such enormous ants is still debated. One leading theory is that higher global temperatures and abundant vegetation around 50 million years ago may have allowed insects to grow larger. The fossil evidence also points to a complex social structure, very similar to that of modern ants. Pseudopolicidae. This family is also known by a simpler name, giant fleas. They were both fascinating and rather terrifying creatures. Giant fleas lived around 165 million years ago. They were much larger than their modern relatives, with some reaching 2.5 centimeters in length. Fossils of Pseudopolicidae have been found in China. Unlike modern fleas, which parasitize birds and mammals, Jurassic giant fleas had mouthparts adapted to pierce the thick hides of dinosaurs or other large reptiles. They likely fed on the blood of these prehistoric giants, similar to modern fleas, but on a much larger scale. The difference in size compared to modern fleas may be explained by environmental conditions and the presence of large reptilian hosts in the Jurassic period. Their larger bodies may have been an evolutionary response to their hosts' defenses, such as thick skin or dense scales. Brontoscorpio. Brontoscorpio was an extinct species of scorpion-like eurypterids that lived about 420 million years ago. These ancient arthropods stood out for their impressive size, reaching up to 1 meter in length. For comparison, the largest modern scorpions rarely exceed 20 centimeters. Unlike today's scorpions, which mostly live on land, Brontoscorpio was primarily aquatic and lived in shallow waters. Their paddle-like limbs indicate they were strong swimmers. They were likely aggressive predators. Their size and powerful limbs suggest they dominated their environment, hunting fish and other marine arthropods. Their large eyes indicate strong vision, important for hunting in murky waters. Their size also suggests they had a well-developed respiratory system, capable of absorbing enough oxygen from the water to sustain their massive bodies and active lifestyle. Giga Titan. Gigatitan was not an ant, but a representative of the extinct order Titanoptera, giant predatory insects related to grasshoppers and mantises. They lived around 240 million years ago, during the Triassic period. These insects had wingspans up to 40 centimeters and strong raptorial forelegs, suggesting they were active hunters. Some scientists believe their wings could produce sounds, perhaps used for communication or mating. Although their exact role in the ecosystem is not fully known, they were certainly among the largest and most formidable insects of their time. Megarachne. For a long time, Megarachne was thought to be the largest spider ever discovered. At first, after its discovery, it was classified as a spider. However, further research revealed it was actually a type of Eurypterid, or sea scorpion. Megarachne lived around 300 million years ago, in a time when giant insects and arthropods were common. The fossil specimen, found in Argentina, showed a body length of about 34 centimeters and a leg span of around 50 centimeters. Megarachne lived in freshwater habitats and was likely a predator, using its size and strength to capture fish and smaller aquatic creatures. Its strong claws indicate a powerful grip, useful for holding prey. Meganura. Imagine a dragonfly with a wingspan of almost 1 meter. These were the Meganura, a prehistoric genus of insects that lived around 300 million years ago. Their impressive size makes Meganura one of the largest flying insects in Earth's history. Scientists first discovered the remains of these creatures in the late 19th century in France. These fossils allowed us to look back into a time when the high oxygen levels in Earth's atmosphere may have supported the existence of such large insects. Their size suggests that Meganura probably hunted other insects and small amphibians. Their anatomy, especially their large eyes, indicates that these giant dragonflies had excellent vision, very important for a predator. Their wings were not only large, but also uniquely structured, providing agility and maneuverability in flight, much like modern dragonflies. Paleodictyoptera. These insects lived around 300 million years ago and resembled giant dragonflies. Some species had wingspans of up to 55 centimeters, making them among the largest insects of their time. Their anatomy was unusual. They had large, well-developed wings, which likely made them strong flyers. However, unlike modern flying insects, their wings could not fold back over the body. They also had elongated mouthparts, which were probably used for feeding. This suggests a specialized diet, perhaps sucking plant sap or feeding on spores. Carbonemys. Carbonemys was a genus of prehistoric turtles that lived about 60 million years ago, after the mass extinction that wiped out the dinosaurs. The name Carbonemys means coal turtle, as their fossils were discovered in coal mines in Colombia. They had enormous shells over 1.5 meters long, making them some of the largest turtles in history. Their massive shells provided strong protection, while their large, powerful jaws suggest a varied diet. They could have eaten small vertebrates, fish, and even crocodiles. The existence of Carbonemys during that time is very important for science, as it helps us understand life on Earth after the extinction of dinosaurs. With the dominant species gone, many animals, including turtles like Carbonemys, evolved to fill new ecological niches. This era marked the rise of many large animal species. If you found this video interesting, don't forget to leave a like, write a comment, and of course, subscribe to Cost War Television so you don't miss new videos.